bum, bum. This is fundamental to our calculus. Part 2. How do we evaluate definite integrals using the fundamental theorem of calculus? I put it up there. If f is continuous on AB, then it's the antiderivative evaluated at the end point. Let's go ahead and get into one. This one down here. I have the integral of x to the minus 2/3 from 1 to 8. What's that antiderivative? Well, we're using the general power rule. We're using the general power rule. That means we're going to add one and we're going to divide by it. We're going to add one and we're going to divide by it. So I have x to the minus 2/3 plus 1 divided by minus 2/3 plus 1. And then we have new notation. Boom. I'm going to put that bar behind it. Yeah. And then I'm evaluating it from 1 to 8. That's new notation. Great. So let me go ahead and let's add those fractions. Let's add those fractions. Did I do something?
No.
Oh, that's to the 1/3. That's what you're saying. Okay. So that's x to the 1/3 divided by 1/3. But some of you may have heard dividing by a fraction is the same as multiplying by its reciprocal. So I could take back that 1/3 and instead multiply it by 3. And we are still evaluating it from 1 to 8. And that's the part that we're doing now. Oh, this could get messy because I'm way down here at the bottom. So then that's 3 and the cube root of 8 minus 3 times the cube root of 1. And what is that? That's 3 times 2, which is 6, minus 3, which is 3. Is that right? I'll take it right here. And your answer is 3. It's the old sit and sleep ending. But we got another one. We got another one. And another one. Boom! This guy. It's a little bit more exotic. But you don't know how to integrate that the way it is. But you need to manipulate, massage it. Yeah? We need to separate it. Because we're simplifying this integram before we integrate. Wait. So that's v to the 3rd over v to the 4th plus 3v to the 6th divided by v to the 4 dv. Is that right? Yeah, that's right. So then I can simplify that. V to the 3rd divided by v to the 4th. What is that? That is 1 over v. Whoa, that doesn't look like a v. That does. And I can simplify that 3v to the 6th divided by v to the 4. What does that simplify to? Okay, so let's get rid of that and call it 3v squared. And now we can integrate and then evaluate. So we can do that now. So, how do you integrate 1 over v? It's the natural log of v. Oh, boy! Just sneak that in there. That's the natural log of the absolute value of v. Plus, now we add 1 and divide by it. But these are designer problems, so they work out. 2 plus 1 is 3. Divided by 3, I have 3v to the 3rd over 3. True. But 3 over 3 makes 1. Ah! Back that up. So I have v to the 3rd. Is that right? And then our new notation, boom, that's going from 1 to 2. Oh. So now we can go ahead and use that fundamental theorem of calculus. We have the antiderivative, so that's the natural log of 2. That's an ugly 2. That's better. And then that's plus 2 to the 3rd. And then it's going to be minus this whole thing, using lots of colors. This thing's starting to look like a Tijuana taxi. Yeah. So then this is the natural log of, some of you giggle because you've seen one. They're colorful. Very colorful. Okay, and then that's going to be plus 1 to the third. Because I'm taking that antiderivative, and I'm evaluating at its endpoints. I'm going to take it to the top. What's the natural log of 2? It's the natural log of 2. Leave it exact. Leave it exact. So that's the natural log of 2. And then we're going to add 8 plus 8. Great. Next. Oh, what's the natural log of 1?
0.
That is 0. Oh, watch me. Watch me. 0. So then all I have left in there is a minus 1. So I'm going to go ahead. I'm going to put that up here. So then that's a minus 1. Yeah. So what it all comes down to, it's the natural log of 2 plus 7. And then what? Oh, look at that. It's the natural log of plus. No. Back it. 2 plus 7. And then what? A box. That's not a flower. That's not a flower. What is that? What is that?
Barbecue.
That is a barbecue, because that's how I like my math. Well done.